Let's check to see if you remember how to solve trigonometric equations. So it says, how would you solve the equation sine of theta equals 0? You know that theta equals 0 is one solution, but this is not the only solution. Any one of the following values theta is also a solution. Negative 3 pi, negative 2 pi, negative pi, 0, pi, 2 pi, 3 pi. So any integer value of pi. So the way that they write it is the braces, and they write in pi such that n is an integer. So integers are positive and negative whole numbers, by the way. So what's the idea if you want to solve a trigonometric equation? Because trigonometric equations, we can think of a circle. The idea is do the circle once from 0 to 2 pi, and you're going to find solutions, maybe more than one. But then you could keep on going around and do another loop around the circle and find the same solutions, and keep on going in the positive direction, the counterclockwise direction. You could also do the same thing in the clockwise or the negative direction. You could keep on doing loops around the circle, and you could keep on finding solutions. So the idea is every trig equation, if it has a solution, it has an infinite number of solutions just by going back and forth in the positive direction and the negative direction. So writing a solution to it isn't like x equals 5. Writing a solution to it would be like 5 plus 2k pi, where you keep on going around the circle, each circle being 2 pi. So you do k where k is an integer. So difficult to write the answers here simply conceptually though. Okay, let's think about this one right here. It says solve the equation sine of theta equals negative root 3 over 2. So remember, sine is y values. Root 3 over 2 is the bigger. So we're going to be looking closer when the y value is, where the angle is closer to the y-axis. Sine is y, root 3 over 2 is bigger. So with root 3 over 2 would be when y is closer to the angle is closer to the y-axis. But I also need my y values to be negative. So I'm not in quadrant 1 or 2, I have to be in quadrants 3 or 4. So when is sine going to be the bigger one? It's going to be at these two angles right here where my y value is bigger. So this would be negative root 3 over 2. And this would be negative root 3 over 2. So we have to think about what are those angles. So I'll do the first one in red. That first angle right there, well, this would be 3 pi over 3. So the next one would have to be 4 pi over 3. And the next one would be 5 pi over 3. Okay, remember the pi over 3s are closer to the y-axis as well. So it seems to me that we would have theta would have to be 4 pi over 3 and 5 pi over 3. And if you don't believe me, put sine of 4 pi over 3 and 5 pi over 3 into your calculator, and let's see what you get. Well, hopefully you get negative root 3 over 2, which is what I got. So I just verified that those are the two answers. But the question is then, are those the only answers? And the answer is no, because what I could have done, instead of my red angle being just that angle, I could have actually gone around the entire circle and then come back to it, right? So what would that be? Well, that would be 4 pi over 3. Think about that being 4 pi over 3 plus 2 pi. You agree with that? Well, did I have to go around the circle once? Couldn't have I gone around the circle twice? Couldn't have I gone around the circle the other direction, which would be a negative 2 pi, or a negative 4 pi, or a negative 6 pi? So how do we do it? We would write it like this. X such that x equals 4 pi over 3. We could write it as 4 pi over 3 plus 2k such that k is any integer. Okay, that's what it would look like right there. We could also do the same thing with 5 pi over 3. So we could say 5 pi over 3 plus 2 pi times k, where k is any integer. Okay, so that's how you would write the general solution for those problems. Are you going to be writing general solutions in a calculus course? Most likely not. Just know that there's an infinite number of answers. Usually when we solve trigonometric equations, we restrict the domain, meaning we only care about the first lap around that circle. We don't have to add the 2 pi k in there. In fact, that's what you see in the next problem right here in example 5. You can see that we quickly restricted the domain to 1 lap around the circle. but there's a little bit difference of this one. So let's look at this. It says solve cosine of 2 theta equals 2 minus 3 theta. Well, this is going to require us to do some of our trig substitution. We're going to have to remember how to do some of these problems, okay? So please, let's think about this a little bit and take a moment to step back. So if you go back to one of the previous pages, you might remember one of the double angle formulas for cosine of 2 theta. I do want to let you know that I can see a typo in this problem already. This is cosine 2 theta equals 2 minus 3 sine theta. This is actually a typo because that's impossible to solve. I want you to solve cosine of 2 theta equals 2 minus 3, and that should say sine of theta. The way that I knew this was a typo is what I'm doing is working through the e-text, and this is directly a problem from the e-text in section 1.4, which is our trigonometry review, okay? So what I also want you to remember is I want you to remember the double angle formulas. Cosine of 2 theta had a bunch of different double angle formulas. Let me write this down. Cosine of 2 theta had a bunch of different formulas, but in particular, what we want is either all sines or all cosines in this case. So cosine of 2 theta, one of the double angle formulas was 1 minus 2 sine squared of theta. And how did I know to use that one? Again, because the right side of this equation had sines in it. So when I go back and I look at cosine of 2 theta, I really know that that's 1 minus 2 sine squared of theta. And on the right hand side again we have, 2 minus 3 sine theta. This is going to turn into a quadratic type function because you have a sine squared, a sine, and a constant. So what I'm going to do is I'm going to get everything on one side of the equation and set it equal to 0. So I'll add 2 sine squared theta to both sides. And I'll subtract 1 from both sides. Combine like terms and let's see what we would have. Well, if we added that 2 sine squared theta, I'd have 2 sine squared theta. Then I have a minus 3 sine theta, minus 3 sine theta, and then I added 2 minus 1, so I'd still have a plus 1 equals 0. You may or may not, I hopefully hope you do, remember u substitution. So for instance, imagine if u is sine of theta. Let's think about what this equation would be. Well, this would be 2u squared minus 3u plus 1 equals 0. And hopefully now you can see it as a quadratic equation. Solving quadratic equations, we talked about this in the algebra review and in the functions review. I don't care how you solve quadratic equations in this class. Do you know how to factor them? And if you don't know how to factor them, could you at least do the quadratic formula? Remember, the quadratic formula is negative b, so that would be a positive 3 in this case, plus or minus the square root of b squared, which would be negative 3 squared, minus 4 times a, which is 2, times c, which is 1, all over 2 times a, which is 2. So this is going to give me my values of u. If I do this, plug this into your calculator. Again, you're going to have to plug this into your calculator twice in a sense. So I'm going to hit the n over d button. I'm going to do 3 plus the square root of, and then I'm going to do parentheses, negative 3, square it, minus 4 times 2 times 1. I hit the down arrow to get into the denominator, and I do 2 times 2. I'm going to hit enter, and my calculator is going to give me an answer. The first answer I got is a 1. And then instead of retyping all of this, what I'm doing in my calculator is I'm hitting the up arrow twice, so the entire problem that I just entered, that 3 plus the square root and all that, is highlighted. Hit enter. I'm going to hit the up arrow again and then the down arrow, and now I go into the beginning of where it typed it in, and I can just go over where it says plus and change it to a minus. So essentially all I did was copy and pasted, and all I have to do is edit. Instead of 3 plus the square root of, I change it to 3 minus the square root of. Hit enter and it gives me the other value. So that's u equals 1 and u equals 1/2. But the idea of u substitution would be then we go back, and instead of u, we know u is sine theta. So this is whereas sine theta equal to 1, and whereas sine theta equal to 1/2. Okay, so I need to think about those values. Sine is my y values, so when in the unit circle is sine of theta equal to 1? Sine of theta is equal to 1. The y value is 1 right here. That's the point 0, 1. That's at theta equals pi over 2. Let's think about sine theta 1/2. Where is sine theta equal to 1/2? Well, that's the y value is 1/2. That's the y value still has to be positive, so I'd have to be in quadrants 1 or 2. 1/2 would be closer, my y value would be smaller, so I'd have to be closer to the x-axis. So that'd be these two angles right here. That first one being pi over 6, and then next one being 5 pi over 6. So I know this is at theta equals pi over 6 and 5 pi over 6. Okay? So what's my solution? We have pi over 6, 5 pi over 6, and pi over 2. Pi over 6, 5 pi over 6, and pi over 2. There's my solutions to this equation right here. So again, I apologize for the typo in there. Make sure you work through it. Let me know if you have any questions.